audible to all of you guys. All right. So I welcome you all here. My name is Premkumar Sampath. I'm an MS Advanced Computer Science student. I'm also the Student Chapter Liaison Officer in BCS Hertfordshire. So today we are going to talk about AI in healthcare. What is artificial intelligence and how we are going to apply it in healthcare? Yeah. So let me just quickly walk you guys through the agenda. So we will start with a brief overview of what AI is and the types of AI, just to set the context of like what we are discussing here. And then I will talk about how AI is implemented in healthcare. After that, we will be just going through a case study, my very own project that was data acquisition lung disease classification of classification. After this, about the challenges that we face in acquiring data sets in healthcare, and how can we efficiently create models even with limited data sets. After that, I will be talking through some points about the regulations and responsibilities of AI in healthcare. And then we will be talking about the future directions. And finally, we will be ending with a Q&A. So artificial intelligence. I think like all of us today use artificial intelligence on a day-to-day basis. So like based on this, can you guys just give me a vague example of what artificial intelligence to you, according to what you guys think? Can anyone tell me?
What is AI?
Yeah.
Anything which learn from previous experience, probably a digital program that learn from previous experience and try to perform better.
Might be a correct definition. So what actually artificial intelligence is? Trying to mimic human cognitive behaviors. So these are systems that can learn from data, recognize patterns in them, and make some decisions that are somewhat similar to human decision making. So we will often see AI being applied to areas like visual representation. We can see image recognition software, speech recognition software. They can even translate languages from one language to another. So that's something what AI can do. So what are the types of AI? So far, the first type that we cover is narrow AI. We can also call it as weak AI, since since it's only sorry. Okay, so we call the narrow AI the weak AI because it's only designed to do one particular task, and the model here cannot learn a different task on its own. It requires human intervention to train the model to do a specific task. For instance, if I have a model that can detect pneumonia on a lung disease, on a lung X-ray, chest X-ray, if I want to use the same model to detect lung cancer or any other anomaly on the chest X-ray, it will be a bit difficult because since the human needs to train the AI to do such things instead of the AI doing it on its own. So this is what narrow AI is, and everything so far, all the achievements we have been doing in AI so far comes under narrow AI because a human trains the model to do a particular task, but it can do that particular task better than a human, but outside its defined scope, it can't do anything else. And then comes general AI. What general AI can do is it can learn from its past experience and the current data to learn new skills. So now the AI can train itself to learn a new classification skill. This will eliminate the need for a human to train these AI models. So this will eliminate the developer who trains these models. And then comes artificial superintelligence. Now, these are AI models that can surpass the human cognitive behaviors. So these possess this kind of feels like a Skynet from the Terminator movie. So they can feel emotions, they can have their own needs, they can make decisions on their own without any human intervention. So far, except for narrow AI, general AI, except for narrow AI, both the general AI and super AI are just theoretical concepts. We have no proofs of their practical applications. So let's talk about AI in healthcare. So AI, be in a normal clinical situation, just talk about two questions every time. So a physician has to either ask whether to treat a patient, or if yes, how am I going to do this? So that's this condition called congestive heart failure. So I'm sorry. There's this condition called congestive heart failure. So what does that mean is, if your heart is not pumping enough, but it is pumping enough. So these are some of the rare cases in medical science that when we meet cases like this, we the sorry the physicians it kind of is difficult for the physician to make a decision on such one. So what we do is we get the data from the patients, their ECG reports, the genetic expressions and everything. We train a model on this method, and then once the model is trained and tested, um, when a physician or when a patient comes with a similar case, a physician can ask this model about the symptoms, and what if someone previously had the same problem, and if yes, how the patient was treated. So how AI fits into healthcare is they can either help us to classify the disease or predict what's going to happen next. So people often confuse the word classification with prediction, because like in AI research, people always say we will hear that I examine this X-ray and I predict this to be a pneumonia. Now, if you are examining some images or something and predicting that and saying that's generally known as classification. So if I'm saying what is that, that's classification. That's not predicting. Predicting is something that's going to happen in future, but I have an idea. I can tell it further time. So yeah, this is the case. This is the project that I've been working for a while. So I created a classification model that can classify between pneumonia and normal X-rays. So here I use ResNet 50, a pre-trained model. It has a stronger performance in classification stuff. So instead of training the model from scratch, I tried to use transfer learning to fine-tune the only the final layers, final fully collected layers of the model to adapt to the medical images that I gave it. So in the top, you can see an X-ray with bacterial pneumonia, and the bottom is the normal condition X-ray. Okay. So the data set I used was the pediatric pneumonia chest X-ray data set. Now this data set, this is a publicly available data set. The problem with this data set was the imbalance in the classes. If you can notice, the number of data points for normal cases and the number of data points for pneumonia are different. So if I'm training a model over this data set, the model will learn more on the dominant class. So while predicting cases for pneumonia, it might be useful. But when I'm trying to predict the normal cases, the model might not perform well. So in that cases, we need to think about collecting, we need to think about how to process this data. So for that, the model to be trained properly. So the techniques I used in this study was transfer learning and data augmentation techniques. And it got an achieved accuracy of 95%. Does anybody have any questions on this? Okay, so when we are using pre-trained model, that set of model libraries that's available in PyTorch. So if I using based on your framework that you're using, so I use PyTorch on this model. You can also use TensorFlow. So you can import from a library the model, and then you can either train the entire model from from scratch, or just train the fully connected layers, the last layers, based on your data. Yeah. So the ResNet 50, the pre-trained model, this was trained on ImageNet. This was trained on ImageNet dataset. So this is the Google's dataset that consists of 1,000 classes with 1,000,000 images. So this model was already trained on 1,000,000 images. So for classification purposes, so it can classify between 1,000 classes. So that's something.
We have a question from the online audience. What does 95% accuracy mean? What does false positive mean? What's the false negative? What's the percentage of false negatives?
I'm gonna can you see it again?
Chat.
Okay, so. So.
Yeah.
Can't see the chat actually.
Chat the Zoom.
Yeah. I think there's some issue with the chat.
The question is about.
Okay.
Okay, just answer that. Yeah.
So 95%. I'm sorry. Yeah. The 95% accuracy states that the model tried to, whenever the model when we tested the model on the validation data set, it worked. It predicted almost 95% of the time the right things. So when the model was initially trained, the model accuracy was somewhere around 87 or 85 because of the imbalance in the data sets. So then upon doing some, sorry, we will discuss that on the next slides on how I worked on the imbalance, how I worked to balance the data sets. That's something.
Another question. What was the performance of a human radiologist on the same data set?
Okay, so this was a dissertation research project, so we don't have an actual performance review from a practiced radiologist. Okay, so let's talk about the challenges, challenges while acquiring these data sets. One thing in medical data sets is the quality of data sets. So whenever we talk about data sets in any field in AI, there might be in picture form, where there might be in audio form or anything. But when it comes to medical data, we always look at the timeline of timeline of the data. So if I am predicting a disease or diagnosing a disease, so I need to check when the patient entered the hospital, what kind of test they did, what kind of results that came, and then based on that, I can make a prediction or a classification. So when we have this vast variety, vast modality of data, like we got ECGs, we got X-rays, we got blood test results, etc. It's there might be some issue with there might be some missing columns, there might be some distorted images, there might be noise to some of these X-rays. So these are some of the points that affect the quality of this data set. Second one is the imbalance in data sets. Imbalance in data sets normally applies that if I'm using a big data set and one class has more data than the other, in this thing is like 1:3 ratio. What does this makes the model is, this impacts the model in a way. The model will learn more about the dominant data class. So in this way, if this model, for example, if it is deployed in a clinical setting, it might also get sometimes the normal cases as pneumonia as well, which might be a problem. Again, privacy and regulation. So every other country has some privacy, some regulations for data. In UK, we got the GDPR and the Data Act 2018. So what these acts generally do is regulate the way we acquire this data, store them, share them, and use them in a transparent way. So this kind of is a necessity as a privacy situation for an individual. But when it comes to acquiring large amount of medical data, it kind of is a difficult process to get this data and get this data, structure them and use them in a no. Okay. The next thing is limited public datasets. I think this is one of the important challenges in acquiring data. The thing with getting the data collection processes, it's so expensive and time-consuming process. Institution needs to hire physicians and who have an idea of data science to label these images or text or whatever kind of data they are using, and then structure them. So these institutions, they are very cautious about the sharing the data due to the privacy risks of the patient. So most of these data sets that we try to get for medical data, they will be private. In order to access this, you might need to fill out a form, you might need to have GDPR certificate on view. So after all this, acquiring a private data set makes it so harder. And it not only affects the limit research, but also the reproducibility of the research. So if I'm seeing a paper, if I want to reproduce the results, and I'm going to the data select section, the data set they use might be anonymous, so we can't get them. That's something. Is there any questions up to this point?
No.
Okay. So apart from all of these challenges, how do we create a data efficient model? A model that can perform well, that can produce similar results even with the low amount of data sets. So one thing we can do is transfer learning. So what basically transfer learning is, instead of training the entire model from scratch, we mute all these models and just train the last fully connected layer. Because like in a convolutional neural network, the fully connected layer is where the classification takes place. So if I'm training the fully connected layer over the data set that I have, so I don't need to go through this entire process. So I can produce similar results with lesser number of epochs, with less time in training. Another thing is data augmentation. So since we have imbalanced data set, one thing I can do is either upsample the normal case or downsample the pneumonia cases. But the thing with this is 5,856 images, already a smaller data set. If I'm further going to reduce the number of data points from the pneumonia cases, the model is going to either overfit to this data set and cannot generalize properly over the new data sets. So what we can do is take these normal images, try to do some augmentation to them. So augmentation simply is either flipping the images, taking up blurring some pixels of the images. So what this will do is the model, although the model won't consider them exactly new images, this will allow the model to generalize more on the normal cases as well. Okay, next is synthetic data. Since we are using generative AI now, we can also create synthetic data that is an artificial image of an artificial image similar to the original data training image. So how this works is the GAN network generally consists of a generator and a discriminator. So the generator generates these images from a random noise and gives that image. Now that image works as an input to the discriminator. What the discriminator does is tries to distinguish between the fake one and the real training image. So in a way, the generator tries to fool the discriminator by creating more the fake ones that are not so similar to this, not as same as the real training images. Mm. So the GAN network is trained to a point where the discriminator cannot really find the distinction between the real one and the fake one. So at this point, these networks are used to create more samples that we can use them as a replacement for these augmentations and still upsample the number of normal cases and then train the data on them. I personally am not working more on the synthetic data, so should know more about the output, how they're going to affect the research. So what kind of regulations we have so far and what are the developer responsibilities? So first thing is regulatory bodies. In UK, we don't specifically have a law for AI, but we have some sector-wise laws that helps to implement AI in healthcare. For example, the MHRA UK, they have this regulation. So if I'm using AI tool in a clinical setting, it is considered as a medical device. So it should go through the regulations of these regulatory bodies so that they can ensure the model that we are using is safe, it's reliable, and it is intended to do what it is doing what it's intended to do. Another thing is data compliance. So we do have the GDPR Act to regulate how data is stored and secure. So this allows secure data sorry. Okay, the data compliance. This allows how patient data can be stored or used in these models. So this ensures that the patient data doesn't leak away while doing the research. And then there comes the clinical responsibilities. Although AI is a tool that we use in medical science, we can't substitute it for human intelligence. So at any given point in a clinical setting, AI might give you an answer, but the health professionals should be the final people who are making the decision. So if anything goes wrong in that setting, the algorithm is not something that's responsible. So the system that implemented the algorithm into the workflow, that should be the responsible. And developer ethics. So as developers or researchers or institutions, we do have our own responsibilities by creating these AI models. We should make sure that these models are safe. These models are doing what they were, are working on their purpose. They don't have any bias on the data set. The data should be diverse. And one of the important things I think we need to talk about is talking about the limitations of the model. So whenever we create a model, there might be cases at which the model might fail to predict properly. So when you are deploying an AI model in a clinical setting, it is important to talk about these limitations as well. So that's the future of AI. So far, we are trying to use AI in diagnostic ways. So in future, AI can also be used to provide personal care based on an individual's also recommend based on your data, your patient data. Yeah, it can give you personalized medical care on your personal data. So this means in future, if I have a problem, someone similar might be having the same problem, but our bodies might be different. So and the AI model can provide different treatment regimes to both of us. And next thing is digital twins. Digital twins are like the virtual models of patients. So this will allow the physicians to know how a patient will react to a particular treatment before actually treating them in that way. And that's explainable and trustworthy AI. So to most clinicians and medical practitioners, AI is always considered as a black box. So we just think like we give it an input, we get an output. What happens in between, we have no idea about that. So when explainable AI comes, it will provide the reasons of why it took a decision. So AI can diagnose something. It can say why it diagnosed it in a particular way. So this will increase the transparency in these models and create a trust among the physicians to enable them to use AI on a day-to-day basis. And finally, if AI advances, it can also bridge the global healthcare gap by bringing these expert systems to the underserved or in regions where specialists are not available to the limit. And so, you guys have any questions?
So I would say that the ResNet model.
Yeah.
Because there are so many models.
Yeah, the model that I used was ResNet 50. Oh, sorry. Yeah, so the model I used was ResNet 50. It has 50 hidden layers divided into 4 convolutional blocks. So on this specific project, I tried to train the fully connected layers, but yeah, I also tried to train the last 2 convolutional blocks as well, providing different precision score. Accuracy scores.
Okay.
Yeah. I also did some training on the last convolutional layer as well. So it's the thing, like based on the settings, you can do some tweakings to these layers and start working on them. Did some hyperparameter tune.
Question online.
I can't see the chat.
When selecting training images, do the control images only include healthy lungs or also lungs with people who were diagnosed with something other than pneumonia, but which might present with similar symptoms.
As for this data set, the description of the data set doesn't mention anything about diagnosing people with anything other than pneumonia. So in that case, that would be all these lung diseases should be either normal photos, normal images, or pneumonia images.
Another question. What are the steps generally to get regulatory approval for use as a medical device from MHI or GDPR specs?
I generally don't have an idea about it. Yeah.
Oh,
Is there anything else? Okay, so, oh yeah. The data set, the pediatric pneumonia chest X-ray. So for this study, I didn't create a synthetic data because they didn't implemented this GAN network. So what I did was I did data augmentation, some downsampling on the pneumonia cases, and the source it was available on Kaggle. So that's a research paper on this data set. There was a paper with a list of data sets. I might just put it at the end. Yeah, this was this data set was taken from a health institute in China. So it basically is a data set